In this video, we will demonstrate how to install the dispersion technology DT1202 particle size and Zeta Potential analyzer for concentrated suspensions and emulsions. The DT1202 is comprised of two components: an electronics unit which houses all of the necessary electronics and the sensors which are used for making measurements. These sensors include acoustic sensor for particle size, Zeta Potential probe, aqueous conductivity probe, which is optional, temperature probe, which is also optional, pH probe, which is optional as well, burettes for titration, also optional. There are several types of stand for accommodating these probes, allowing for sample handling with or without mixing, as well as minimizing sample volume. This setup is the standard DT1202 setup. This chassis holds the acoustic sensor, which can be equipped with different sample chamber setups depending on the goals of the user. The standard sample chamber allows for measurements with all probes, as well as mixing with the magnetic mixer attached to the bottom. This mixer can be replaced with a pump adapter, which allows for mixing to be performed instead by an external peristaltic pump. The minimum sample chamber decreases sample volume to 20 milliliters for situations when only particle size is to be measured. If sample volume for particle size needs to be minimized even further, below 10 milliliters, we can use this setup. The model which uses this setup for the acoustic sensor is called the DT1210. If particle size measurements are to be made online, we can use this setup, which utilizes a rubber cross mold, allowing for continuous flow through of sample. This model is referred to as the DT500. In the case of the DT1210, Zeta Potential measurements can be made outside of the acoustic sensor sample chamber, either using the ZP cup accessory, dipping the probe directly into the sample, or using an alternative ZP sample chamber. Part 1. Setting up the instrument. There are several connecting ports on the rear of the electronics unit. The mouse and keyboard are plugged into the two USB ports located on the back. There is an additional USB port on the front of the instrument which can be used for a flash drive. The monitor is connected via an HDMI port located here, and the power cable is plugged in here. At the bottom of the rear of the electronics box are a series of ports for the sensors of the DT1202. The amount of ports here varies depending on the options purchased with the instrument. All sensors can be plugged in by hand, requiring no additional tools. Be sure, when plugging in the sensor cables, to properly align the plug with the port in order to avoid cross-threading. The ring on the plug is turned clockwise until it locks into position. You should feel it click into place when the plug is fully connected. Once everything is plugged properly into the DT1202, the instrument can be turned on. The green button located on the front of the instrument is the power button. Press it once to turn on the instrument. When the DT1202 turns on, it will go through a series of steps. First, it will load Windows. After Windows has finished loading, a DOS screen will appear, which runs through a series of checks. After all of the checks have been completed, the DOS window will disappear and the instruments will be ready for use. Be sure to wait for the completion of this DOS checklist before starting the DT software. Now that the instrument has fully booted up, the instrument has been fully installed and is ready for use. Part 2. Making measurements. The first step in making measurements using the DT1202 is to open the dispersion technology measurement software. The icon for this software is located on the desktop and can be opened by double-clicking on it. Once loaded, 3 windows will appear on the desktop. The first window is the welcome window, letting the user know that the software has been started and is in the process of booting up. The second window is the instrument status window. This window lets the user know which options are included and available on their instrument. The software takes about 2 minutes to start up, running through a series of checks with the necessary boards and drivers of the instrument. Upon completion, we are left with only the third window, the home screen. The home screen is divided into two sections. On the left-hand side, with the green background, is the experiment design section, where we designate what kind of measurement we want to make. If we want to make a particle size measurement, we would click attenuation for size. If we want to make a zeta potential measurement, we would click CVI for zeta potential. In order to demonstrate the capabilities of the instrument, we will click both to make both types of measurements. If we wanted to make multiple measurements or run a titration, we would designate so in this section of the home screen. On the right-hand side, with the orange background, is the sample definition section. Here we define the sample we're measuring, the liquid medium, the dispersed phase, and the concentration of the dispersed phase. We can also include a sample ID for the measurement, which helps with record keeping and allows for this data to be more easily found in the database later. We will now demonstrate how to make a measurement of 10% silica ludox. We first load the sample chamber with our solution. We then define the experiment we plan to run. Since we are going to make both a particle size and zeta potential measurement, we check attenuation for size and CVI for zeta potential. We then move to the sample definition section and define our sample. We set the liquid media to water, the dispersed phase to silica ludox, and the concentration to 10 weight percent. Lastly, we click the large run button to begin the experiment. Particle size measurements take roughly 7 to 10 minutes to complete depending on the nature of the sample. Zeta potential measurements are quick measurements taking between 15 seconds and 2 minutes. Upon completion, an analysis window will appear. The section in green at the top will report the zeta potential, which we see is negative 38 millivolts. Below we see the results from the attenuation measurement. The attenuation data is on the right. We have the raw attenuation data in dark blue triangles and then two curves attempting to best fit the data with a unimodal and bimodal distribution. For whichever fit the instrument deems is better, the corresponding particle size distribution is presented on the left. The curve here shows a unimodal distribution with a median size of 30 nanometers. Part 3. Verification. There is a form that allows for verification that the probe is functioning properly by displaying the signal level at different junctions inside of the probe. This form can be reached from the home screen by selecting View, Grid Raw Data. This will bring up the Grid Raw Data window. On this form, we select View, Signal Level. For attenuation, this signal data looks like this. For CVI, the signal data looks like this. Measuring attenuation of water is a good method for verifying that the acoustic sensor is working properly. For CVI, we use 10% silica ludox. You can find a snapshot of this form with proper values in the manual. Part 4. Calibration. The acoustic sensor measures attenuation at a given frequency as a function of distance. Because of this, it does not need to be calibrated. Zeta potential probe must be calibrated. Zeta potential calibration is done with the same 10% silica ludox that we used in the prior section. In order to calibrate the instrument, on the home screen we select Calibration, Zeta Potential. A separate window will appear. From the drop-down box, we select 10 weight percent silica ludox as a standard we are going to use for calibration. We make sure that our probe is properly submerged in our solution, and then we click OK. The instrument will then perform a calibration measurement. Upon completion, the instrument will report the measured zeta potential and CVI phase. These values should be within 1 millivolt and 1 degree of the standard values. If they are, click OK and you are good to go. If not, press OK and then repeat the calibration experiment until those values are within the acceptable range. Once you've completed calibration, your instrument is ready to go and you can begin making measurements of your samples. For more details on how to operate the dispersion technology DT1202, an operating manual is stored on the instrument itself. It can be reached by going to Help, Operating Manual, PDF format. We hope that you have enjoyed this brief video about the dispersion technology DT1202. If you have any additional questions, you can email us at info@dispersion.com. Thank you.